Hello, and welcome to the Scientific Adventures of Beardman. Today we're going to be looking on physicsclassroom.com under the topic Electric Circuits at the concept builder titled Resistance Ranking Tasks. So resistance is one of the three main characteristics of an electric circuit. Electric resistance tells you how hard it is for the current to flow through that particular material. So how is that material, how much work is it doing at slowing down the current? Okay. And in particular, this concept builder is looking at how a wire would produce electrical resistance. Okay, we say a wire, it could be any object. If we change it in one of these two ways, either make it thicker or make it shorter, how does that affect the resistance and therefore affect the amount of current that can go through the resistor? So the first one is the thicker the wire, the thicker the resistor or wire in this case, the more room for electrons to move through it. Okay, and therefore there's less resistance, which means that you could have a bigger current. In other words, you could have more electrons moving through it each second. A thinner wire, the opposite, they would have more resistance and fewer electrons can move past each point each second. So as you look at these two, this is like our thick wire. There's lots of lanes for the electrons to travel through. Over here, there's only one lane for the electrons to travel through because the wire is so thin. Okay, here it's nice and thick, and so a lot of electrons can go by each point each second widthwise, and here it's thin, so not as many can go through each second. So keep in mind, even if all the cars over here were going 65 miles an hour, and these were all going 65 miles per hour, if we picked a point on this freeway, there would be more cars crossing it each second here than here. Okay, there's more resistance to the flow over here because there's just not as much space for them to get through, you could say. It's a good way to think of it. Once again, these are analogies. The cars are analogies, so they are not a perfect example of why, but they give you the idea. Okay, then if we look at the shorter resistor, okay, well, as electrons go through a wire, they experience resistance, right? This is the idea of the stoplights. It's resistance going down there, okay? Well, the shorter the road, the shorter the wire, the less stoplights you're going to run into. Now, it's a little bit different. Like I said, it's an analogy. It's not perfect. In cars, this car has no impact on what happens to this car way back here, unless there's a whole line of them. But these cars are not attracted or repelled from each other like electrons are. Electrons have a force interacting between them. And so when one of them is slowed down, that kind of slows all of them down because of the way that they're interacting. Okay? So the shorter the wire, the fewer obstacles the electrons have to move through. So the shorter the wire, the lower the resistance, the less resistance it provides. So the resistor that's shorter has a smaller resistance. The opposite's true as well. The longer the wire, the more resistance. Okay, and then in the activity, you have some examples. We see a short wire, a medium wire, and a long wire. And you just have to say which one has the most resistance and which one has the least resistance. Okay. So we had just finished saying that the shorter wire had less resistance, and I think they used the term smallest. It's not working. Come on. Okay. The smallest resistance. Okay. The longest one has the most obstacles, so that has the greatest resistance. And the medium one has a middle, so it is in the middle. Middleist resistance, I believe, is the term. So that's what you'll see in the first one, resistance and length. The second one is resistance and area. And so in this case, the thicker one, that is like the 7-lane freeway, because electrons can go there, 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 there. Okay, they can go anywhere, so there's a lot less resistance here. This will have the smallest resistance. And the one where it's a 1-lane highway, right here, there's only 1 lane through there. That's going to have a great resistance because it's hard to get a car through there. Great. How about I put a T in there and then an E? Now I can put the S. There we go. And then the one that's a middle area will be the middleist resistance. Okay. And then finally, we'll see putting it all together. Okay. Which I didn't bother to do. That's right. Because it's really just a combination of these two. Sometimes you'll see a long, thin wire, which because it's long, it would be greatest, and because it's thin, it would be greatest. So it's going to be greatest. And then you'll see a short, thick wire. Well, if it's short, it's got the smallest resistance. If it's thick, it's got the smallest resistance. And so you mark that the smallest. All right. Well, enjoy puzzling out the resistances of various wires on the concept builder here. As you remember our car analogies, that the thicker the road, the less resistance there is, and the shorter the road, only one stoplight would be the least amount of resistance. All right, we'll see you next time on the Scientific Adventures of Beardman.